Hi, this is Austin T. This is Lab 2 for Machine Vision, Contrasting Objects. We're just going to jump right in it. I feel like crap from the COVID vaccine, so let's get started.
And then we have two different lights over here. We have a yellow LED lamp over here, and then we have a white LED lamp over here, followed by our camera, which is mounted on this rail through zip ties. Fortunately, it can't be moved up or down, but you know.
Okay, so our first test is going to be circles. We are using the Find Circles test in the openMV examples, and we're going to be testing lighting first. So first of all, this current setup right here has really good lighting. Here's a lamp directly above, shining down on the objects, really contrasting the circle, especially this brown one right here. And then we're going to switch to low lighting by turning off the lamp. And as you can see, it's intermittent, especially on the brown lid over here. This white lid over here, the shadow from the room light kind of casts a little circle. So it looks like the software picks that one up a bit. Let's see. Yeah, even then it's having a hard time, like especially when you move it around. This shadow too over here really distorts the outline of the circle over here, so I don't think it's picking up this blue tape roll right here. And then we will switch to no lighting, which obviously should not detect anything like that. All right, this next test is with contrasting background. You have the white sheet of paper and several circles over here that contrast that white paper. And this is definitely your ideal setup over here. As you can see, this blue tape has a blue ring and a good separation from the background that allows it to pop out. Same thing with this lid. And then we have a shiny metal lid over here. And that contrasts really well because there's a little like divot over here that also gets a shadow. So even when we move it around, the software is able to pick it up. And definitely this is what you want. You want lighting overhead, casting some shadows where you need to, and also a contrasting background. All right, so the next test, we're going to be testing no contrast on the background of an object. We're going to be doing the circle test again for this. As you can see, this brown circle over here is roughly the same color as a desk, and the software has a difficult time differentiating it even with some shadow on the lid edge. However, if you notice this little circle over here of light, its reflection from the light, that's a good way to test the contrast in and out. So, for example, if we bring the brown lid under that light, the software picks it up pretty well. But once again, once we move it out of the light, software does not have a good time. Tested a couple different threshold values as well, and they all seem to have some difficult times. And this next test, we're going to be using a white sheet of paper here as the background, and we're testing how well other white circles blend in and a translucent glass over here. So as you can see, this thing with the button, it's actually a cup lid. It detects pretty well, most likely due to the shadow caster on the edge over here. Software is able to pick that up fairly decently. This cup though, even with the shadow, it software seems to have quite a difficult time. Let's try this solo. It seems to pick it up a little bit when you move it. A little bit better when it's directly under the light, but even then it's kind of iffy. See, sometimes it's kind of popping in and out, pops in and out too when you move the glass. So a little bit difficult with this translucent object, even though there's shadows. So this next test, we are testing the fine line segments code, example code. And over here, we have a wide array of objects. We got circles, we got straight edges with multiple straight edges packed together. These are screwdrivers all packed in a set. We have curves over here, organic curves, and then we have just regular straight edges. And it does a pretty darn good job of detecting line segments, even when you do things such as you rotate the straight lines like this. It still picks up all those screwdrivers in the set. There's about, I think, 6 of them total. Detects the edges. And then you have organic shapes like this headphone over here. Detects the straight lines along the flowing path here. It's pretty impressive. And then you even have circles over here. Detects little straight edges on the edge of the circle. Looks kind of like an old school back in the day, the early video game days where circles are pretty much just a bunch of big straight lines all joined together. Interesting thing with the circles is that if you take this, for example, this brown lid out of the contrasting background, you kind of lose some accuracy here. See on the bottom edge over here, sensor cannot pick that up as well. So you definitely need a contrasting background. We will also switch to the edge detection with Canny, which turns this picture into black and white. Makes it a little bit easier to see, I think, with the human eye because it contrasts. Let's turn it right now, and it should pop up like that. Now it looks definitely like old school, like 8-bit game. Reminds me of Asteroid. But yeah, it's increased frame rate as well because it's black and white, so not as much data processing. Easier on your system, and you still have the little problem with the circle over here, detecting the edge. You know, it is what it is. A lot easier to see, I think, general outlines of objects. Maybe harder to determine depth or what kind of object without the color, but you know, if this is the application that you need, this one might not be a bad idea. Okay, so this is the grayscale binary filter. What it's going to do is attempt to convert grayscale to a binary black or white. So in our sample image here, we have a contrasting background, the white sheets of paper again, and contrasting objects. We have a grayish multimeter over here, and then we have our blue screwdriver set, and we have an object over here that's not contrasting as well, which is a grayish whitish calculator. And then we have two settings for this code over here. We have the low threshold. The low threshold is pretty good for edge detection. It's but it is not as good for edge detection as the high threshold. However, with the low threshold, you can also pick out details pretty good. We'll run the code in a second, and you'll be able to see it. Okay, let's hit the green button, and then we'll pause it on the low threshold snap. So this is the low threshold over here. Edge detection is still pretty good on the multimeter and the screwdriver set. So as long as you have contrasting objects, it detects it pretty good, the edges. And also the details that are, as long as they're contrasting again from the background, they're pretty good. I mean, you can see some of the buttons over here and a label on the multimeter. You can see some of the, looks like the edges of, or the little grooves on the screwdriver that also contrast really well. This blue pick thing. However, on objects such as a calculator that don't contrast too well, you got a not really any outline at all. Um, the buttons are not visible. The only thing that's contrasting is the screen over here. So now we'll switch to the high. And as you can see, the high, the edge detection tends to be sharper and more bolder, again, as long as it's contrasting. Now, it seems the high threshold is more dependent on the light. As you can see on the right side of the picture here, the light is shining pretty good on the paper, and that allows you to see some of the buttons over here popping out. So possibly the high threshold might be best suited if you have a strong light that is shining down on contrasting objects. Even semi-contrasting objects like this calculator, you can still see some of the features over here. In fact, you know what? I'm curious. Let's try see if we move the calculator over directly closer to the white light. So that was not bad. So we move the calculator over closer to the light source. The light source is also more diffused compared to last time. It's a softer white light. But yeah, this is the low threshold picture over here. You can see the calculator buttons, even though they're more well lit, they are not contrasting at all on the low setting. However, on the high setting, you can see the calculator is much better contrasted. The edges, the details, when it's directly underneath the light. So that's a pretty good image right there. You can probably pick some edges out over there. However, the other items that are further away from the direct light source are still blacked out. So it's really more dependent on what your situation is and your lighting and what contrast the object is and what kind of shape. And this next segment is for the rectangles. It detects all these rectangles in the red squares over here. And looks like the rectangle corners with the green circles does have a little trouble though with this circular lid over here. Tries to classify as a rectangle and all the corners keep jumping around.